All right, friends. Good morning, good afternoon, good evening, depending on where you have joined from. The next session is on connect your data artifacts with Azure Synapse Analytics. And I have with me another MVP from Microsoft, Data Platform MVP, Wolfgang Strasser. Such an honor to host you, Wolfgang. Thank you very much for taking out time from your schedule.
Yeah, thanks for inviting me and welcome to my session. Before I dive into my session, I'm gonna share my screen. And thanks again for inviting me and welcome everyone to 1 hour full of Azure Synapse Analytics. My name is Wolfgang and I would like to dive into this new thing called Synapse Analytics. Let's see if it's really new. Let's see what is new, and let's see how all those pieces are put together. And today, I'm going to focus on 1 hour of the topics, and the training class, it's 8 hours of Synapse Analytics deep dive. But today, well, my name is Wolfgang. I like to work with data. I like to talk about data, and I like to write about data. So together with some colleagues, I published the second edition of Power BI for Dummies, but only in German. But yeah, Power BI, data ingestion, data preparation, data warehousing, everything that comes with data is part of my day-to-day job, and I really enjoyed it. If you have any questions, please feel free to put them into the Q&A window, and we will answer them at the end of the session. After the session, if there are any questions, here are my contact details. So why is there the need for another analytics technology in Azure? Why is there the need for another thing to analyze, to prepare, to model your data, and even to visualize your data? I think it is very well related to the fact that even those small businesses, or let's say every business, is a data business. Data starts to get the lifeblood of our economy, of our businesses. It's not the thing that those big companies are only those companies that use data, like having a data warehouse, having a reporting solution, and so on and so forth. Especially during the last year with the COVID crisis, I've seen in Austria, I'm based in Austria in Europe, many small shops that only had a physical shop, they moved into the online business, and they had to do some data analysis because they had to know what are the things we need to order and so on and so forth. And they weren't really used to do data analytics and some reporting because they had a shop before, and now they are dealing with reporting. And there are some slogans on that slide, and there is one, I think you already heard that one. Data is the new oil. And that one is a quite commonly heard one, but it's not a new one. That one is from 2016, so 15 years ago. The topic of data is the new oil, data is the future was mentioned. And there is one thing in that part, it's mentioning that data, well, it's valuable, but if it's not refined, it cannot really be used. And that is one part of the story of today, because if you have data and you collect data, but the data isn't clean, you won't be that satisfied with your reporting needs. And there's another sentence I found, and I really liked it. They compare data with water. Like water, data and water needs accessible, but it needs to be clean in order to survive. So clean water to survive, and also clean data to survive your business. So a really good point of mentioning that data and just collecting data, it's not the best solution. So you have to think about cleaning your data, combining your data, bringing and bridging different data islands together. And what we also see is a trend or two different streams. There is that kind of data warehousing stream, which we have on the right side here, which is that structural, well-structured relational data. It's the data integrated coming from different ERP systems, CRM systems, and so on and so forth. And that is the foundation of reporting for many years. So we've built data warehouses with many customers, and we had structural sources like SAP or other systems, and we combined those information into, again, a database, a data warehouse. And data warehousing, it's focused on business analytics. So it's the thing, what have we spent, how many customers did buy that category or that specific part, product, and so on and so forth. On the other side, during the last years, there was another thing that came into the area of analytics. It's the data science. It's the machine learning. It's the data lake. It's not the structural definition of a database. It's the data lake to collect, to store the data, to work on, for example, IoT, Internet of Things data, sensors, production machines, every kind of thing in your company that produces data needs to be stored somewhere, all those sensor values. And the data science, well, it's that part of data analytics that tries to learn out of your data, but beforehand, they sometimes really don't know what to look for and what is really in your data. And those are the two big streams. So data warehouses, business analytics for the structured storage and requirements. And on the other side, the data lake to store semi or non-structured data, and also the data science to, well, dive into your data, to explore your data, but sometimes you really don't know what to look for in your data. So two different streams. And there are also other options we have to consider, because data is not like data. Data can be structured, semi-structured, non-structured, as I said. There can be data that is delivered in a data stream, like the IoT data. So machines continuously push all their values into some sort of streaming system. Data can be produced on premises, stored on premises. Data can be produced on premises and stored somewhere in the cloud. Data can be big data. Data can be small data. Data can be stored in a database. Data can be, coming in different flavors, as you can see on that slide. So there are many options that are only focused around data. And data needs to be analyzed using different technologies. So what we have is a huge list of different technologies to work with data. Data warehouses, I've already mentioned them. Data lakes. We have tools for data visualizations. We have different kind of structures. We have spreadsheets that are very important in many companies. We have machine learning technologies. We have data stored in a data warehouse or smaller data marts. We have data models that somehow structure our data. We have commercial tools. We have open source projects. So many, many options around the technologies. And last, but definitely not least, we have the people. We have the skills of the people that work with the data. We have people coming from the SQL field, coming from the database area, like myself. I started my career in data warehousing, data integration. So SQL Server and everything around that universe, it's my technology. But there are people out there that really like to work and do data cleaning in Python, in R, in other tools. They are good in data modeling. They are good in data cleansing. They are good in writing SQL queries, and so on and so forth. So many different options. Having the people, having different skills, having different kinds of data and different kinds of technologies. Well, that sounds like, I want to go back to my good old times and work with a data warehouse. But is the data warehouse, the good old data warehouse, the structured data warehouse, is it still relevant? I think yes, but it's a part of the overall story, because we have those huge list of different options, technologies, data structures, and skills. And we have to look for a way how to solve and to deal in the best way with our data requirements or analytic requirements. And there is no let's go left or right decision. It's a really, it depends, and especially it needs to be combined decision. And there is also the question, well, should we analyze our data on premises or should we move into the cloud? And today, well, the answer will be we should have a look into the cloud, because the data warehouse in the cloud, the modern data warehouse, is a thing that can work with all those requirements, and we can address different requirements. And the slide you see here, it's a proposed architecture from Microsoft, and we are dealing with Azure services here. And that is an architecture before Azure Synapse Analytics appeared on the stage. So what we need to do in order to work with data is we need to have data sources somewhere. So data sources on the left side. We have data sources here, and we need those data sources to be read and stored somewhere. So, and there are two technologies listed here. It's the Azure Data Factory to load the data, transform the data, and store the data. In that architecture, we have a central storage, which is based on a data lake storage, Azure Data Lake Storage. It's a cheap but very, very powerful storage. And for addressing those two different areas, as I already said, the data warehousing and the big data science approach, there are two technologies mentioned here. Let's start with the data warehousing part. That one was called at that time Azure SQL Data Warehouse. That one is now part of the SQL or the Azure Synapse Analytics. And that is the massively parallel data warehousing technology from Microsoft, having 60 databases in the background, data distributed, compute nodes, working with the data, and so on and so forth. Really, really powerful to address your data warehousing needs. On the other side, in the middle, we have Azure Databricks. And that one is a technology to address the big data, the machine learning, the data science requirements. And that one is called Azure Databricks, but it's not a service that comes directly from Microsoft. Databricks is a commercial company that built a product based on Apache Spark. So distributed data analytics, Apache Spark, open source, but Databricks is a commercial product that builds powerful extensions above the open source Spark product. So data coming from the sources via the Azure Data Factory into your storage, and two different pillars to work and transform the data. On the right side, we have external tools like Azure Machine Learning to build some machine learning models based on your data, and Power BI for the visualization. And those tools work great. They work great. They are really, really good working with the requirements to analyze big data, data warehousing, and data ingestion. But Microsoft thought, well, it's a good thing, but maybe we should consider some sort of umbrella. Maybe we should consider a thing that does and can deal with the data ingestion, big data workloads, and data warehousing workloads. And that was the idea and the birth of Azure Synapse Analytics. And Azure Synapse Analytics, it's a border around different technologies. And we will see that some of those technologies you've seen here, or similar technologies like on that slide, will have a rebirth in the Azure Synapse Analytics Foundation. And now let's dive a little bit deeper. So that white box in the middle, that's the Azure Synapse Analytics workspace. And within the Synapse Analytics workspace, we've got different types of technologies in there, or different types of processes that need to be addressed. We've got the data sources on the left side. So on-premises data sources, cloud data sources, IoT, streaming data sources, and different kinds of services, and so on and so forth. What we need to do is that part. We need to get the data from the sources, integrate the data. So we've got the integration here into the central storage, the Azure Data Lake storage. It's again the Azure Data Lake storage. And it's not a new technology, it's the Azure Data Lake Storage Generation 2, which uses or is used by Azure Synapse Analytics as one of the central storage options. And within your data storage in the data lake, data alone, it's not that kind of interesting. We need to analyze the data. So we need some analytic runtimes. And here comes into play the different skills of people and the different requirements to work with the data and the different structures of the data. SQL is very, very good for dealing with structured data, relational data. But for semi-structured or even non-structured data or big data, well, we need other types of analytic runtimes. And under the Synapse Analytics umbrella, we've got two flavors of runtimes. We've got the SQL-based runtimes, and we've got Apache Spark-based runtimes. We will dive into those two different kinds of flavors deeper in a minute or two. And what we need to work and develop data integration logic. We need to work and write analytic statements. We need to work and create Spark-based development. And that one is or can be done in the Azure Synapse Studio. That one is the unified experience part of the story. It's a development environment in your browser, in your Azure portal that is used to develop, but is also used to manage your environment. And it can also be used to monitor your integration pipeline runs, to monitor your SQL jobs, and so on and so forth. And in addition, and definitely not last to mention, it's security. Those three pillars we've seen on the previous slide, Data Factory, Databricks, and SQL Data Warehouse, they had different kinds of permission sets. They had different kinds of levels, how to configure your permissions. And with the Synapse Analytics workspace, we've got one foundation. It's the Azure Active Directory. That is really the base of your security. And security in the different pieces of your Synapse Analytics workspace, they are all based on Azure Active Directory. So one of those four pillars, it's security, and it's an important one. But how you might ask yourself now, so many different options, different kinds of flavors, different kinds of analytic runtimes. So what is really in there for me? And I would say, let's dive into a demo to see Synapse Analytics in action, because slides are good, but the demo, I think it's a little bit more interesting to see all those pieces, how they work together, how we can use them, and if you're coming from the SQL side, how easy it is to work with those different pieces. I've opened my Azure portal here, and I already created a Synapse workspace in here, but let's see. Let's create a new one. Let's start to create a new one. I'm gonna add Azure Synapse Analytics here, hit the create button. And one thing to mention, well, the number of the resource group and managed resource group, not that interesting. We need to think about a workspace name. So the name of the white box in the middle we've seen on the slide. And there's one thing to mention, the data lake storage account. The one that was gray on the slide, that one is required. Every Synapse Analytics workspace needs one data lake storage account as a primary storage account. You can use databases afterwards, but that primary data lake storage account is really, really required for storing metadata for Synapse Analytics and so on. It's a requirement. And everything else we could enter here, well, yeah, security, network related, and so on. That is the thing we need. The right name for your workspace and the primary data lake storage account. And up next, yeah, I'm here in my demo Synapse workspace. What we see here is an overview about the different pieces that are put together. So the Synapse workspace itself, it's not that much. The Synapse workspace, it needs and takes other pieces and puts them together. And what are those other pieces? Let's have a look here. If I scroll down, I see a list of analytic pools. And there are two different flavors. So we've got the SQL-based ones, and we've got the Apache Spark-based ones. In my environment, I've got two Spark pools or Spark clusters pre-configured in two different flavors, so two different sizes. I've got a small and a medium size prepared for that. What is really important to mention here, the Spark pools are configured before, and you only start them whenever you need them. And you are charged only when the pools are running. And you can pause the Apache Spark pools. So no requirement to have a Spark pool running 24/7 all day long. You start that cluster, you work in the Spark environment. When you're done, there's even an auto shutdown or auto pause option in there. And for the SQL pools, in my environment, I've got 3 pools in there. And there are 2 types of pools that can be created. And the serverless one, that one is created by default. So every Synapse Analytics workspace has one built-in, one serverless pool. And the dedicated pools, SQL DB1 and SQL Pool 2, those are created by myself. So what is the difference between the serverless and the dedicated pool? The serverless pool, maybe you've heard about that technology, serverless. It's a SQL engine that is there for you whenever you need it, and it's paused and shut down if you don't need it. So the serverless pool is really a thing that is charged by the data it is processed using the serverless pool, and it's there and it scales if you need more power, and it's just there. So we will see some sort of use cases whenever the serverless pool is the right thing to use. The dedicated pool, it's different. The dedicated pools are coming from the Azure SQL data warehousing part. So those are Azure SQL data warehousing databases. And the dedicated pools, we configure them, and it's similar to the Spark pools. We configure them and can configure them in different performance levels, data warehousing units. And the smallest one is the data warehousing units 100, and you can scale it up to 3,000 or more. And what is the difference in between? The data is distributed for the dedicated pools. We have 60 databases in the background. So data is distributed in 60 data distributions, equals to databases in the background. And we have a cluster. We have compute nodes that are distributing the queries, collecting the results, and pushing it back to the control node. And whenever you scale all those SQL pools up, you get more compute nodes, you get more options to store the data, you get more processing power, and so on and so forth. So it's the slight bar of performance that is involved there. One big difference between the serverless and the dedicated pool, the serverless pool is not able to store data. The serverless pool is able to create data references to elements in your data lake, to create and have external tables, but it's not able to store data in a serverless pool. The dedicated pool, well, here it's your turn to store the data in there. And now let's dive into the Synapse Studio. As I mentioned, it's the development environment, and the Synapse Studio can be opened here using the open link. And in the Synapse Studio, we've got 4 big buttons in the middle. And those 4 buttons, well, the first 3, those are the things I would like to show you, and those are the processes we are dealing in Synapse Analytics when we want to analyze data. We need to ingest data coming from somewhere and store it in the Azure Synapse Analytics workspace. We need to explore and analyze the data. And last but not least, well, visualize the data, build it interaction into colorful and powerful reports. And the last part, the last button you see here, it's the learn button. And that one is a really, really important one. If you are new to Synapse Analytics and you don't really know where should I start, what is there, how can I use, are there examples for Spark pools, are there examples to analyze data in SQL? Well, there are examples. So if you open the Learning Center, the Knowledge Center, we get a list of samples and a sample gallery. And the sample gallery is perfect to start and build a demo environment and to learn how Synapse Analytics works. There are data sets you can analyze. Data sets ranging from small diabetes data sets with having 400 rows up to New York City taxi data having millions or even billions of rows to analyze. And if you not only want to have data to analyze, maybe you want to start with a notebook, a Spark notebook to work on your data, to build machine learning models and so on and so forth, have a look at the notebook section. So many different options, many samples already prepared from Microsoft to start your Synapse journey. SQL scripts, it's the same, and pipelines. And what is the thing of pipelines? And that is the thing I want to start with. We need to ingest data into our Synapse environment. And pipelines, for those of you that know Azure Data Factory, maybe you've heard and worked and even created pipelines. And pipelines are a thing to load data from somewhere and to move the data to somewhere. And in our Synapse environment, we've got different hubs. Microsoft calls them hubs. I would say menu entries, different menu sections. And there is one that is called data, and there is one that is called integration. And the integration hub gives us the entry point to our pipeline development. And if I open that one, for those that have seen Azure Data Factory before, I hear, hey, I know that user interface, and you are right. It's Azure Data Factory. It's almost 100% of the same source code, but it's integrated in your Synapse environment. So you don't have to switch tools. You don't have to move to Azure Data Factory to build your data ingestion, your data integration pipeline. It's integrated in Synapse, in your Synapse workspace. And it's not called Azure Data Factory here. It's called Synapse Pipelines. And you can build pipelines. You can configure a copy data task to read data from somewhere, from your source, and to store the data somewhere. And that is the part where we are extending our knowledge, and where are we building bridges between our data islands are those data sets. And behind those data sets, we have that concept of linked services. And linked services, if you know Data Factory, you know linked services. If you don't know, and if you haven't seen the concept of linked services, I'm going to show you a short thing here. It's a connection to a system. It's a connection to a file. It's a connection to a database somewhere. And we define a new linked service. For example, for or addressing a managed SQL database, managed instance in the cloud, or a SQL server. SQL server, somewhere we have the SQL server that is running on premises, or even an SAP system or an Oracle system. So databases can be a linked service, or we can have Azure Databricks, Azure Machine Learning, and so on. Even files stored somewhere in the cloud, somewhere on a website, or on a file system on a local machine. So it doesn't matter where your data comes from, if it's on premises, in the cloud, if it's a database, if it's non-structured, if it's structured, if it's an Azure service, if it's running somewhere in another cloud. The list is huge. I think we are about 100 different sources that are supported. And those linked services allow us to connect to the outside, to read the data, to get the data into our environment. And that is the first part of the story, data ingestion. So data ingestion pipelines. And we can build data ingestion pipelines having different steps, like getting the data from a website, writing the data to a data lake storage. And next, we've got one piece that is called data flow in there. And what we can even do is we can build data transformation logic within Synapse Analytics pipelines. And if I go to the development hub, I've got one thing or one section that is called data flows. And in the pipeline that is still open here, I open tell my pipeline, after the initial copy task, execute a data flow. And if I open the data flow, I get another part of the data ingestion story. It's a mapping data flow. And that mapping data flow, zoom in a little bit, allows us to read data from a data set. And a data set is a more specific definition of a piece within a linked service. So we have a linked service, and we can have different data sets. For example, a data set to address the customers table in a database. Or in that part, it's the linked service is an Azure Data Lake storage address. And we have a data set that addresses a specific file in that data lake. And within those mapping data flows, we graphically can define a data flow and different steps of data transformation. Like in that part, there is a mapping. I can select and rename, and there was a typo in the initial file. We can add filters like only movies after 1950. We can get into the preparation and having some ranks in there. We can aggregate things, and after everything is done, we can write those results to a sink, to another data set or a linked service. In our example, it's a database. So we are reading data from the data lake, transform the data, prepare the data, and write the data to the database. And now back to the overall pipeline. That is the data flow. And afterwards, we can copy the data again to another data set, or in that case, to a dedicated pool. So data ingestion, it's one part, and we can build powerful ingestion pipelines in there. And we can build ingestion pipelines to read the data from, it doesn't matter what source it is, 90 connectors, 90 plus connectors. And we can write the data to, let's say, for example, our data lake storage. And within the data hub, we can have a look at the linked services. And there are many, or not many, there are some linked services already registered in my environment. And there is one, it's the primary one. So we see the primary here, and we can use the integrated storage explorer to analyze the data in our data lake. So we can start having a look at the data lake, the integrated storage account, and we can have a look here. And we can have a look at a file, right-click within that Storage Explorer, and for example, preview the content of that specific file. What we can also do, we can go to another directory, go over here and preview again. And that is population data of Upper Austria, the part of the region of Austria where I live. And what we can also do in the right click in the context menu, we have some actions we can perform. There is one part built into the Storage Explorer, which deals with the management. So we can define security in there, manage access, who is allowed to read the data, who is allowed to write data into that folder in the data lake, and so on and so forth. But there is also those two entries, new SQL script and new notebook. And if we select the new notebook, select top 100, let's see what that action generates for us. Well, we now move into the SQL development environment, which is again part of the Synapse Studio. And the Synapse Studio, I already told you, we've got two different flavors of SQL analytic runtimes. We've got the built-in one, and we've got the dedicated one. With the built-in one, one of the use cases for the serverless, the built-in SQL pool, it's data exploration. And what do I mean with data exploration? Well, we can have a look at the CSV file in our data lake using SQL syntax. Select star from open row set, and that's the magic command. Open row set defines the location I want to read. It's the CSV file in our data lake and the CSV format and the parser version. And if I run that one, we get back the content of the file, but let's think back. The preview, we had beautiful columns, we had column names and so on and so forth, and those are missing. But let's see, there's a column separator, and there is an option I can add here. So it's the field terminator. And if I add the semicolon here, run it again, and we should, fingers crossed, we get 5 columns. And what we can do now is we can get a little bit more structure above the selection of the file in the data lake using a with clause. So I can add a with clause, which tells the SQL script, column number 1, its date code. Column number 2, city code, city name, the year, and the population. And what we need to do is we need to skip out that line, that first header line. So we've got an option that is called first row, and I set the first data row to row number 2. Run that one again, and hop, we get a SQL statement that is executed against a file in the data lake. But what we get back is a relational table structure containing the information out of the CSV file. And what we can do now is we can have a look at the town, my hometown, city name, and it's a small town. 4,000 inhabitants, and we have data up until 2019. And if we get back to the data lake, there's another file which contains the 2020 population data. And what is really, really handy is we can add wildcards into that bulk location. And if I run that one again, in the background, the serverless pool queries all the files that match my wildcard. And what we get now is 2019 and 2020 data. Up next, we can analyze and explore the data. So we've got a charting built in here, and let's put the year on the category, and I want to have a look at the population. That one isn't ordered right, so I'm just order the statement by year, run it again. And it loses the configuration. So do it again. And we've got a small, nice visual based on data from the data lake using the SQL serverless pool. So very, very nice. And what we could do next is we could develop some sort of structure, or what we could do is we could have a look at the database. Because I said the SQL serverless pool is not able to store data, but it's able to build some kind of logical layer above your data lake storage or whatever. And there are 3 different kinds of databases within your Synapse Analytics workspace. The red ones, those are the dedicated pools. Those are SQL Data Warehouse powered pools. The blue ones, those are databases for SQL serverless. And the green ones, those are databases coming from Spark Analytics. And what we can do, I'm going to stick to the SQL serverless for 1 more minute. We can create a few in there. We can create few structures. We can't store the data from the data lake or move the data out of the data lake into a serverless database, but we can build a few that actually does the same as I built in my statement out there. And we can create a logical layer above your data lake. So a logical data warehousing approach. But be aware, it's not persisted. Every time you query that view, the data goes back or comes back from the data source. And that is one thing you have to consider about the costs, because costs are somehow data involved in there or based on the data. The another approach we can do is for people coming from the Spark side, people that are able to work with Spark, right-click, generate a notebook. And what you see here, it's a similar approach with the compared to the serverless. Read data from the CSV file and work with the data, but not in SQL, in a Spark pool and in a Spark notebook. You've seen notebooks in the previous session, but notebooks, if you don't know notebooks and haven't seen notebooks, it's very, very cool. And I think one of the futures of development, because within the notebook, you can mix code and documentation, markdown cells. And you can even store the results of your code cells within the notebook. So really, really nice. And what we need to work with the notebook, again, we've got the 2 Spark pools in here. So we need to select the Spark pool. And last but not least, skills-wise, Spark is great because within one Spark notebook, you can change the language. You can write a cell using PySpark, Python-based. You can write a cell using .NET Spark, C#, or you can even write and switch to Spark SQL, and you can mix and match those languages. So very, very nice to solve the problems in a language that really solves it in a handy way. When I started working with Spark, I'm coming from the SQL side, and I've got colleagues that are data scientists. They know how to work with Python, with R, Scala, and so on and so forth. And I tried and broke my fingers almost to write some statements in SQL, 25, 500 lines, whatever. And my colleague came and said, hey, there's a function in Python and you get it in 3 lines of code. So that is a good way to mix and match the skills that are out there. So really the second analytic runtime you have in there. Within the develop, so we are now in the flow of data ingestion, data analytics, data storage. And what I've not shown is the databases, the dedicated pools. Within the dedicated pools, we have data stored in there. And data can be stored in tables. Yeah, that's a database. But what is really important is you have to think about the data distribution, because data is not stored in a single database. When you're using SQL dedicated pools in Azure Synapse Analytics, there are 60 distributions, 60 databases in the background. And you have to think about the distribution key. And there are different ones, like hash-based ones. You can even partition the data within one distribution. And there is a round robin. So data is stored to the next database that waits in line. So that is a huge difference between a normal SQL server and the dedicated pools. So MPP, massively parallel processing, is the technology that is behind there. And last but not least, well, there's one thing missing. It's the beautiful reports. It's the Power BI environment that is missing. And what we can do using the linked services approach, we can link the Synapse workspace to a Power BI environment, a Power BI workspace. And I've already done that using the linked services, add new linked services approach. And I've mapped that one to a Power BI service in my tenant. And in the development hub, I've got the entry of Power BI. And there are 3 levels. That one is the workspace. I've got the list of data sets in my workspace, plus the reports. And what is really nice, you don't need to switch the tools, because we just open the list of Power BI data sets, or even the list of reports, and open a report. And what you see here is it's Power BI. It's Power BI integrated into Synapse Analytics. So no need to go to another tool, move or change the tool. You have Power BI integrated. And what is really nice, you can even change your reports if you have the rights to change the reports. And you can add a new visual over there. You can also work with your data, do some filtering, add the required filters you want to use, and so on and so forth. And what is also available is create a new Power BI dataset out of Synapse Analytics. And you can build a new dataset built on one of your SQL databases. So either you use dedicated pools or one of those logical databases attached to the SQL serverless environment. And what you get is you download a PBIDS file, Power BI data source file, which is the connection string and the information where to find data. And you have to build the model in Power BI Desktop. So that is the thing where you need to switch the tools. But whenever you're done, you publish the data model and the initial report to your Power BI environment, and you are done. And then you have a new data set in here, and you can start and create a new report based on your data set in there. And that is really nice because you don't have to switch tools. You just work on your reports. And if you save that one from Synapse, it's also available on the Power BI side because those two are connected. They are not two separated instances. We are working in the Power BI workspace here, and the from Synapse report is also available on the Power BI side. So very, very nice and powerful to get the data into your Synapse environment, to transform the data, to analyze the data, to do data exploration with SQL serverless pools. And SQL serverless pools, it's a huge, huge area. And I've heard rumors that there is another session right after that one that deals with serverless pools. So stay into that content or watch the recording of the next session about SQL serverless pools. And what we've seen, well, it's the idea of Synapse Analytics. It's the idea of connecting data islands. I think that the Synapse team had one thing in mind or in their brains. Synapses in our brains are there to get us better, to learn. If we connect two brain cells using the synapses in between, well, we are able to learn. And that is also the power of Synapse Analytics, building bridges between your data islands. Because data islands, well, are nice, but there is more. It's not only analytics, because Synapse tries to integrate data into one single umbrella, the Synapse workspace, to get an overview, a global overview about your data. But analytics in the organizational environment, it's not everything. There is more, because data islands, well, if they are separated, they are not the best, as we've learned. And we need to build bridges. And sometimes bridges are good to go because we can connect directly to a source system. We can directly connect to an Oracle database or whatever, or Cosmos DB, which allows a direct connection or almost a real-time connection from Synapse. But sometimes those bridges are a little bit more fragile, and we need to look how to get data from one island to the other. And sometimes we don't really know what is there. And those data silos, we've already talked about them, they can be on premises, in the cloud, and somewhere. And if we go a little bit further, Synapse can be one of those data islands in your environment, in your organization, because there are other tools, there are other systems that store, that generate data, but maybe they are not part of your Synapse environment. Why is the question, but there are data islands that need to be connected. And there is one answer that also deals with the data integration or data knowledge, the data catalog. It's another service in Azure. It's called Azure Purview. It's the data governance service from Microsoft. It's in preview since December last year, I think, and it addresses three main pillars. It addresses the data governance approach. Where is your data stored? Is there any specific data in that table, for example, PII data, email addresses, birth date, and so on and so forth, telephone numbers, phone numbers. And data governance in combination with the data catalog allows you to search and map your data. So you get a data map, and that is one of those big pillars in Purview. And one of those islands within your huge data map can be Synapse Analytics. And what is really also important and good to know, the data lineage. Data flows within an organization, as we've seen, using Synapse pipelines, the mapping data flows. And we've got data lineage steps. Data flows from the source to a sink. There are some transformation steps. And that is also part of Azure Purview, the data lineage approach. And you get, well, an overview about not only the analytics platform in the cloud, Synapse Analytics, but also the more general overview about all the data aspects in your environment. What have we seen and hopefully learned within the last 55 minutes? Yeah, Synapse Analytics, another, or is it the analytics platform in the cloud for the future? We are able to integrate data using Synapse Analytics pipelines to store the data into integrated data lake storage, analyze the data using SQL-based pools, analytic runtimes, or Spark-based runtimes, and have a unified experience considering the security, the management, and so on and so forth. And with the combination of linked services, Synapse, it's not just an island. We can connect to Power BI, for example, to integrately work in the Synapse Analytics workspace and build Power BI reports without the need to switch the tools. And with that, I'm at the end of my session. I hope you enjoyed it. And are there any questions?
Q&A panel. So let me just look around. Yes. So let's start with questions. First one is from Kulendra Singh, and the question is, which type of Power BI workspace reports gets published? Is it Power BI service or two other flavors?
It's only the Power BI service. So the linked service Synapse to Power BI, it's only working with the Power BI service workspace. Thank you.
The question is, can we plug Synapse with Azure DevOps for sourcing CI/CD, notebooks, flows, PBIX, etc.?
Yes. I haven't set it up in my demo environment. You can hook it up to, I think it's Azure DevOps, the source control, and Azure, the GitHub, sorry. And you can use source control in there. And you can even use the DevOps CI/CD pipelines to bring your dev Synapse workspace to the user acceptance environment or even the production environment. So that is possible.
Perfect. Well, Wolfgang, thank you so much. This is done and we are bang on time, just about kind of 2 minutes to go.
Perfect.
Perfect. Right, friends, with this, thank you very much, Wolfgang, for taking out time. And it was a lovely presentation. Thank you. Thanks, Wolfgang. See you soon. Goodbye.
See you soon. Bye. Thanks.